Well, we have another question here, question 4. The question says the sketch below shows the graph of f of x, which is log of x base 5, and g of x is equal to 2 over x minus 1 plus 1. Now we have t and u are the x-intercepts of g and f respectively. And the graph y equal to x intersects the asymptotes of g at r and the graph of g at v. Now comes questions. Question 1 says 4.1. I mean, says write down the coordinates of u. Okay, the graph is as we can see there. Okay. Now, so we're doing question 4.1 now. Another here 4.1. Okay, we can see that the coordinate of u, okay, u is somewhere, is over here. So u is the y, actually the x-intercept, and also it lies also on the asymptotes, okay, of g. So we can see that this is the vertical asymptotes. And now if I look at this equation here, this is like this is the equation of the hyperbola, so it's like a x minus p plus q, where p here is the vertical asymptote and then q is the horizontal asymptote. So it's easy to say that u is the coordinate of u is just 1, because the horizontal asymptote is 1, this one here. So 1 p, okay, 0, because it is a x-intercept, so that's u. And then question 4.2 says write down the equation of the asymptotes of g. Now the asymptotes of g, there are two asymptotes. The first one is u, which is okay, the equation will be given by x equal to 1, and the other asymptotes, the horizontal asymptote, is cut over here, so we can just see the horizontal asymptote is also 1. Okay, that's the q, so plus 1, so horizontal asymptotes. Y equal to 1. Now that was question 4.2. Now let's move on. Question 4.3 says determine the coordinate of t. Okay, let's see. T is this one. T is also an x-intercept of g. Now I'm gonna write the question here 4.3. Okay, we are looking for the coordinates of t. Okay. Now t being the x-intercept, which means okay, x-int simply means make y equal to 0. Okay, and then the equation here, g of x is like y equal to 2 over x minus 1 plus 1. Now we are going to make g equal to 0, so y equal to 0. So what that means that 0 equal to 2 over x minus 1 plus 1. So if I move the 1 over, so this will become negative 1 equal to 2 over x minus 1. Now negative 1 like that is like it has a denominator of 1. Okay, you know, all integers are also fractions with denominator 1, so we can just take negative 1 here times x minus 1, and then 1 here times 2. So that's by cross multiplication technique. So this means negative 1 times x minus 1 equal to 1 times 2. So this will make negative 1 times, so we do the negative 1 here times x, and negative 1 times negative 1. So this will make negative x plus 1 equal to 2, and then that will make negative x will be equal to 2 minus 1, and then that makes x is equal to negative 1, x is equal to 1, and that makes also x equal to negative 1. So if negative x is 1, meaning x is negative 1. So we find the x value. Now, because t is the intercept, okay, the y value is just 0. So we only had to find the x value. So this means the point t will be the point -1, 0. So that's the coordinate of t. Okay. Question 4.4. Well, the question says that to write down the equation of h, the reflection of f in the line y equal x in the form y equal to etc. Okay, there's something a bit funny about the question, because all the English that we see here, that says the reflection of the line of f in the line x equal y, all this simply means the inverse of the function. Okay, so we need to find the inverse of the function of f. All right, here question 4.4. So we are looking, basically we're looking for f minus 1 of x. That's the meaning of the words we see there. Now, I'm gonna write over here. Let me just write it properly. Okay, so it's where basically we make y become x and x become y. So now the equation is f of x equal to log of x base 5. So now f of x is the same thing as y. So I'm gonna write y equal to log of x base 5. Okay, I think I can just move my board a little bit this way because of space. Split it like so. This will be what according to the log the logs formulas or definition. Excuse me. I can just write it over here. So we know that d of x equal a, or maybe log of a base b equal x. This implies that b to the power of x is equal to a. So in this situation, okay, that we have like y equal to log of x base 5. Okay, hold on. I want to write it this way. It was that, but now when we work out the inverse of a function, you change the order. Okay, x, you swap the values, x become y, y become x. So this is going to be x equal to this becomes like x equal to log of y base 5. Now we're going to make y subject of the formula. So we have like we're going to write using this formula. This is going to make y. Okay, so because we have like log of y base 5 equal x. Okay, applying the formula above in red, this will become that's 5 to the x equal to y. In other words, y equal to 5 to the power of x. So that's the newer function y. Okay, the newer function h. So h of x, which is the same thing as f minus 1, just equal to 5 to the power of x. So that's. But I wanted to the form y equals to, so we can just keep writing this one. Now, the following question is what? Let's remove the board. I need to see the graph. The following question is question 4.5. Well, the question says, excuse me, write down the equation of the asymptotes of h minus 3. All right, let's remove so I'm gonna write here 4.5. So we are looking for the asymptotes of the function h minus 3. Okay, h of x is the same thing as f minus 1 of x, as we said earlier. Okay. If h of x is just equal to 5 to the x, okay, this implies that h of x minus 3 will be equal to x minus 3, there it will be equal to 5 to the x minus 3, because we're going to change the value of x by x minus 3. Wherever we have x, we write x minus 3. Then this is an exponential function, and then there's nothing next to 5 here. Okay, it's just a 0. So in this situation, the asymptotes is just a 0. So therefore, the asymptotes, which is the horizontal asymptotes, will be always equal to, in this case, it's just equal to 0. Same asymptotes for 5 to the power of x. Okay. Now, the following question is question 4.6. Let me look at the question. 4.6, what does it say? The question says that calculate the coordinates of V. Let's see, where is V in the graph, in the diagram? V, okay, V is there. Just put V is over there. So we need to find the coordinate of the coordinate of V. V is excuse me, the intersection of the two graphs of f and the line y equal x. Okay, so of G, that's G, and this is the line y equal, this line is the line y equal x, correct? So now let's find V. Now I'm gonna move my board over here. I'll try to question 4.6, looking for V, the coordinate of V, so x and y. Now, being the intersection, it means we're going to equate the contents. Okay, it is V is in the intersection of the line of y equal x and g of x, which is, I'm gonna rewrite it here, 2 over, okay, 2 over x minus 1 plus 1. Now we are going to equate, because equate the two equation, because g of x just y. Okay, so that's 2 over x minus 1 plus 1, and there we have like y equal x. So now we're gonna solve the two equations simultaneously, because this is y and that y. So what we're gonna do, we're gonna set y x equal to this. So this will be x equal to 2 over x minus 1 plus 1. So I prefer to move the 1 over. So I take this one, I'll move it over, and then we will have then x minus 1 equal to 2 over x minus 1. Now remember that this part has a denominator of 1, and then what we can do, we can just take this one, this denominator, cross multiplication. Okay, so this will make x minus 1 times x minus 1, okay, equal to 2. And then x minus 1 times x minus 1, you know, we do x times x times -1, and -1 times x, -1 times -1. And then this will make x squared minus x minus x plus 1 equal to 2. So we're going to write here x squared minus 2x plus 1 equal to 2, because we combine these two like terms. Excuse me. And then I'm gonna move the 2 over here. So the equation will become x squared minus 2x plus 1 minus 2 equals 0. And that makes x squared minus 2x minus 1 equal to 0. Now, in this situation, we can solve this by, we cannot really factorize it because I cannot get the value of 1. This equation is not factorizable because negative 1 here will never make a sum equal to negative 2 and then a product equal to negative 1. You can check. Let's check. If I say we have like negative 1 there, what are the factors of 1? Just 1 and 1. Can we get a negative 2? Okay, if you told me that we can make negative 2 if we do negative 1 and negative 1, yes, negative 1 minus 1 makes negative 2, that's true, but negative 1 times negative 1, it makes positive 1, but there we have a negative 1, so it cannot really work. And if you say that it can be positive, one positive and the other negative, 1 times negative 1, of course, we get negative 1, but 1 minus 1 is 0, but we need a negative 2 here. No, not working. Now let's check. What if they're both positive? Okay, 1 times 1 makes positive 1, but we have negative 1 there. And 1 plus 1 will make positive 2, but we have a negative 2 there. So we cannot factorize this situation like this. So the equation is not factorizable. Situation like this, we will going to use the quadratic formula, and then which is given by x equal to minus b plus minus square root of oh, my square root is quite long. Square root of b squared minus 4ac over 2a. Now I'm going to substitute here. X will be equal to minus b plus minus square root of b squared minus 4a and then c, okay, all over 2a. Now let's sub in the values of a, b, and c. So we can note that a is 1, b is negative 2, so I'll sub in negative 2 there, plus minus negative 2 squared, minus 4a, a is 1, and then c is negative 1 over 2a, a is 1. Now I'll do that by the help of my calculator. We can just do minus 2 plus the square root of minus 2 squared b squared minus 4a, which is 1, and then c is negative 1 over 2a is 1. Now when we're going to hit the equal sign, we have like 1 plus square root of 2. So excuse me, this will be x will be equal to 1 plus square root of 2. Now we can also check with the negative. X will be equal what? Where's my calculator? It's there. So now let's check with negative. Minus there, and then when we hit equal, so we have like 1 minus root 2. 1 minus root 2. Now, look at these questions here. 1 plus root 2, this is positive, right? It's more than 0. And then 1 minus root 2 is negative. It's lesser than 0. If you're unsure, you can check in the calculator, press ST. You see that the negative, it's negative, you can see, it's negative. And then the other one, plus, obviously this must be positive because 1 is positive, root 2 is also positive, and the answer must be positive. Positive plus positive makes positive. Now let's see the coordinates of V. In which quadrant is V? Okay, let's see. V is in the first quadrant. So now in the first quadrant here, X and y are positive. Okay, they're both positive. Here, x is negative, y is positive. And then over here, x is negative, y is also negative. And over here, x is positive, y is negative. So this is how it works. So now, v being here, okay, we're going to take it with a positive x value. Okay, because it lies on that, it will be influenced. The value of y will be influenced by the value of x. So now, let's see. Now that we find x, we can just find y by substituting the value in either of x either in this equation or that equation. Okay, I believe that's going to be much easier if we sub over here to find the value of x. I'm not saying if you sub it over here, it's not going to generate the correct answer. It will, but it's going to be with too much work. I always like to select the part that has lesser work. Now, y will be then therefore y also, because y is x, y is also equal to 1 plus 2 root 2. I said we did select this one. Okay. Therefore, the coordinates of v is the points 1 plus root 2 and 1 plus root 2. That's v. Okay. Now I want to take another question. Split my board like this. We have another question like, I guess, 4.7. Let's see. Oops. 4.7 is over here. What does it say? The question 4.7. It says that determine the coordinate of t prime. See, with that t, we can really t prime the point which is symmetrical to t about the points r. Okay, let's read again. Determine the coordinate of t prime, the point which is symmetrical to t about the points r. Where is r? Oh yeah, I see r. R is over there. R is over here. So now we need to find a point, another point t. Let me see the graph fully. Okay, another point t, the point that is symmetrical. Another point t prime, which is symmetrical to t about the point r. First of all, earlier we did find that t was -1, so we have to point -1, 0 here, and then r being at the intersection of the asymptotes. This is just the point 1, 1. Okay. Now, so we need to find another point. T prime, okay, which will be symmetrical to t about the line, about the points r. Okay. So symmetrical has to do with the midpoint. Okay, it means what? Let first, before maybe I'll draw the graph or the points, I'll show you something here. See where t and r are. So t and r are, okay, the 2 points. Now, if you look at the x coordinates from t to the x coordinate of r in the horizontal, for instance, they are apart. They are 2 units apart. Okay, so from this one to that one, they're 2 units apart. So symmetrical meaning we need another 2 units there. Okay, to find the coordinate of t, the x coordinates of t prime. So we count like if I count 1, 2, and then I'll count another 1 approximately there, and then 2, let's say there. So now, how much is it from 0? It's 1, 2, and 3. So this is the x coordinates 3. Okay. Now, from now that's the x coordinates of t prime. Now, from T to R in the vertical, okay? If you look there, you just count 1 unit, just one. So we need to count another 1 unit there from R above. So it's gonna be so if 1 is there, another 1 will be there. So this means that 1, 2. So this is the y coordinate of the point T. So now we can just connect the two and then see we have like the points T prime will be somewhere there, and its coordinates are like 3 and 2. So the point here, the coordinate of it will be so we have like the point T there, which the coordinates are 3 and then 2. You see? Then I can prove it geographically. So I just try to be a bit accurate. If you look at in the graph, for instance, I can just draw it's approximately it's a bit from there. With R is there, and then T. So the line must connect. Yes, my graph was not that bad. So it's like we have something like, yeah, not that bad. So the distance between TR and T prime must be equidistant. That's why they say symmetrical about T, symmetrical to T about the points R. So that's it. Thank you.